Okay, let's get going. Welcome, everyone. This is pretty rapid stuff if you're just watching back-to-back sessions, right? You're jumping around to all sorts of amazing sessions in SQL Server, and huge call out to Simon for putting this together. I know so many of you are dying to see people speak in person, but it's so amazing people like Simon would put together a virtual event so that we can continue to empower you with the knowledge about everything SQL. And so when Simon and I were talking about what should we do with what should Bob do at this conference, because I've spoken on a lot of topics over the years, as you saw on there. It's actually now 27 years, Simon. Can you believe that? 27 and a half years. Anyways, I thought SQL Server containers would be a perfect topic for this conference. I know several of you on this event that are watching and listening are developers. So let's talk about it. But first of all, I want to make sure you are set the stage and have the resources you need. Look at this screen. At this link right here, AKMS Bob Ward MS, which I'll show you again at the very end in resources, the deck is already there. Everything I'm showing you right now in a slide deck, you can go to that website and see this deck. It's under a folder called SQL Server Containers. Let me also show you another resource. Let me pull this over here to the screen so you can see it. This is called SQL Workshops. This is a free GitHub site. And if you scroll down to the SQL 19 workshop, again, everything free on GitHub here, completely for your use. If you scroll in here, the scripts I'm going to use today are right here. You're going to see me go through using PowerShell certain steps on how to run SQL Server containers. So if you're like, hey, I'm watching Bob doing this, I need to get these scripts, they're already for you out there. Okay, and I'll give you these resources again at the end of today's session. Okay, let's go back and let's start talking about containers. So first of all, I kind of want to set the stage a little bit on a few basics of containers. The deck that's out there has some hidden slides of things I'm not going to show you because I only have like 45 minutes, to talk about this topic. But here's just a couple of basics because I'm going to talk more about the SQL Server containers. So first of all, I always like to use this slide to explain my version of what containers are. And the number one thing I emphasize is right here. That containers are really a process run in an isolated manner. It could be multiple processes actually, but many containers are just a single process. You'll see that with SQL Server. So it all starts with something called an image though, an image being a layered snapshot of files, the minimum files you need to run this process structured in a file system. So these images are really cool, and you're going to see how SQL Server provides several images for your needs to run SQL Server containers. Now, when you have these images, a container itself is going to be the runtime instance of the image. And something called a container runtime, and today's example is I'm going to use Docker, is used to go run those processes, these instances of these images. And you're going to learn today in SQL Server some of these other concepts like what's a writable layer and a read-only shared image layer, et cetera, et cetera, et cetera. So I just want to make sure you understood that. A lot of people I've heard say things like containers are lightweight virtual machines, and there's all these things out there, what they are. And look at the top of the right-hand screen here. A virtual machine emulates hardware and loads the entire operating system. A container is a process run in isolation, but cooperates with the host kernel. So you're going to see that actually in the real world, containers complement virtual machines. A lot of people run containers in virtualized environments, and you'll actually see that in example today. Now, there's a couple of things about containers I want to tell you. Number one, under the covers. I'm an under the covers person. I don't know about you. I like to see how things work. It's like, how did Docker, one of the most popular container runtimes, do this? Is there some magic to Docker? Well, as it turns out, not really. There's actually an open source piece of code called libcontainer, also called runc, based on this OCI, Open Container Interface. Libcontainer contains all the source code to do containers, to run containers. And in Linux, these are the concepts from the Linux kernel that are used to make this happen. Like a namespace is used for isolation, or the union file system to layered file systems. That's how we do things like sharing read-only file system images and do writable layers, or control groups, allowing us to do things like governance and accounting or limits of processes. So as it turns out, you too could write a container runtime if you wanted to. You could follow this open container interface, but you could just use concepts from the operating system yourself. And these concepts are used in places outside containers. Now, the last concept I want you to understand, it's really important because this comes up all the time and people ask me, how do Linux and Windows containers work? How does Linux containers run on Windows? So first of all, a Linux container image On a Linux host, that could be a virtual machine, could be bare metal. It's a native Linux process. You could go into the Linux system and see the SQL Server process run on the Linux kernel itself if you're running container image, okay? That's important from a performance perspective, that you understand how SQL Server performs as a container versus running SQL just say in the VM itself. Okay, what about a Linux image on Windows? Well, for the longest time, it required an entire virtual machine running on Windows to make this happen. But now there are two technologies. One's called Linux containers on Windows and WSL, Windows Subsystem for Linux. They support the concept of a virtualized process, but it's still virtualized. So for example, if you're going to try to compare SQL Server performance on Windows as a SQL Server Windows program with a SQL Server container Linux image, that wouldn't be fair because there is still a virtualized process involved and a layer there that could not be fair to compare performance. But if you ran the SQL Server image on Linux and a SQL Server Linux container image on Linux, it would be the same because it's a native Linux process. Now, on Windows, by the way, which today we don't support SQL Server Windows containers, we're still kind of trying to see whether people really want that. We don't see a lot of demand for it, but just so that you know, a Windows image on a Windows host can run in isolation as an actual native Windows process, but we also support something called a Hyper-V isolation. And then today, at least not yet, it's not possible to run a Windows image on a Linux host. So I put this together. I've talked about containers for the last several years. This answers a lot of questions people have about actually how does this work under the covers. Okay, let's go talk more about SQL Server containers now. So first of all, why do you do this? Like, what is the big deal about this container thing? And let's talk about these a little bit. Number one's portability. And I look at it this way from this perspective. You have developers in your organization, and you have a developer server for SQL Server you all share. DBAs can't stand that. Sorry, developers, you're always wrecking the SQL Server. You're changing the configuration, you're running something. You guys are all messing it up because it's shared. Well, go start running containers. Container images are portable anywhere you can run the container runtime. So for example, the SQL Server container image for Linux runs the same and is portable on Windows, Mac OS, and Linux itself. That's pretty cool. So if you've got Mac developers, Windows developers, all trying to run SQL Server, just give them container images to run on their laptops. And we'll talk about how you can use a consistent image of SQL Server along with scripts and other things to give them a complete package to do development testing in their environment. In fact, quick story. So I'm at an event several years ago. You may have heard of it called SQL Bits. And someone in the audience saw me presenting like this and said, hey, I'm not feeling the Mac love here. Bob, you're a Windows guy. You're running a Windows laptop. You're doing everything on Windows. What about Mac people? I don't want to run Windows. I'm like, I got you covered. In fact, I did a challenge for him. I said, within 5 minutes, you can run SQL Server on Mac and a native tool to connect to SQL on Mac in 5 minutes with no Windows software. And he's like, I don't believe you. And I said, well, feel free to get on Twitter and say I was wrong. And so the next day, somebody pointed out to me on Twitter that he said I was wrong. And I was really disappointed. I'm like, man, I really screwed up here. He said he actually did it in 3 minutes. And what he did is he installed Docker on Mac OS. He pulled down the SQL Server image on Mac OS and installed Azure Data Studio on Mac OS, which there's a native Mac version for. And in 3 minutes, he was up and running. So don't believe that you can't do things now. It's all just Windows-based. SQL Server supports these environments all over the place. Now, why is it lightweight? Look at this example right here. Because the fact that containers in their image only need the files they need to run the container image, not the entire operating system like a virtual machine, it reduces the footprint of running multiple SQL Server containers. In fact, in this diagram right here, it could be a virtual machine that's hosting all three of these. This is the new way to do, quite frankly, multiple instances of SQL Server in a more condensed way to compress how you install SQL. So, and then finally, it's much more faster to deploy this. There's no patching required. I know you're thinking that's crazy, but I'll show you how, and a lot less downtime. Now, if you're a DevOps, and we'll explain exactly how that works in a second. Now, if you're a DevOps person and you get the slide deck, go click on this link for this video. At the Build conference in May of 2020, I did a demonstration of how to use Azure DevOps with SQL containers to automate the development production lifestyle. I think you'll love to see that demonstration. You can go through and see exactly how I did it, how I built an Azure DevOps project, use SQL containers to make simple GitHub changes that automated the entire process. And so SQL Server, we believe, is a big part of the DevOps lifecycle because we now support containers. Okay, So let's move on for a second here and talk about the images of SQL Server. How do you find these things? So first of all, the Docker Hub and Red Hat Container Catalog are great places to see where we show up as container images, all the different flavors, okay? But we keep them in the Microsoft Container Registry because that is owned by Microsoft, and we ensure the security of these images in that environment. Now, what do we provide? For SQL 2017, this is where we first started with Linux containers. Every single SQL 17 build, the GA RTM of SQL 17, each cumulative update, each security update that we have, all have separate images, and they're all cumulative. So you can go right to SQL 17, cumulative update, whatever, and there's no need to apply the general availability and apply another version like you would do in, say, Windows. And it includes the SQL engine and tools packages. In SQL 19, we now have upped the game. We provide different versions of Ubuntu per your needs and different versions of Red Hat now based images. But again, we also have general availability, cumulative update, and GDR packages. So you're thinking to yourself, what about that faster deployment thing? What did he mean by that? Check this out. SQL Server now, SQL Server is pre-installed in a container. When you see me run this thing, it's all ready to go. There's no installation required. You just run the container and you've got SQL installed and up and running. And the tools are pre-installed. And then the other part that's amazing, this is the SQL Server engine on Linux. So database and applications are completely compatible. You're just connecting to the SQL image like you would SQL Server Linux. And I've talked before in many different other sessions that SQL Linux engine is the same engine that we run on SQL Server on Windows. So don't think that all of a sudden now I run a SQL Server container and I've got to make all these changes to my code. No, just take your code, take your Management Studio tool, Azure Data Studio, point it to SQL Server container, and you're ready to go. So those are the different engines of SQL Server, and this is why you're going to want to use containers. This pre-installed concept, I've seen a lot of people now in the industry that are doing demonstrations for SQL Server. Speakers are now completely using containers in their laptop because it's so fast and easy to get this up and running. Okay, how do you do this? And this is an example using Docker, and we're going to see this as a demonstration in a second, but I thought it important to kind of walk through the pieces of this. So first of all, when you run a Docker container, you can pass environment variables to the process that's going to run the container. In this case, it's SQL Server. So we have documented and there's a link for this, we've documented what are environment variables that are possible for the SQL container. Now, two of these that are required are accepting the EULA, the license agreement, and the SA password. Because right now today, even though we've started support Active Directory authentication, in order to get this running, you must supply an SA password. Now, you can also use other environment variables, like if you want to enable SQL Server Agent, you can do that at the same time. You're going to see as well, I'm going to encourage you that if you want to make configuration changes to SQL, to the instance like memory, you could do it through the same concept when you run the container. The next is the port. So SQL listens natively on port 1433. And if you were to run several SQL programs that all tried to listen on that port, they couldn't do it. You'd get an error. So therefore, you can map ports. So I typically do this no matter if I'm running one container or 5 containers on a VM or a computer. Now I will connect to port 1401 for this specific container to get to the specific container instance that I just ran. The volume becomes very important, and we'll talk a little more about that later, but this is where you're going to be storing your databases and files to ensure something called persistent storage, because if the container went away, you would lose your databases if you didn't do this. And we'll talk more exactly what that means. But this name, SQL volume, Docker is going to map that to a known directory on your host or your VM system where these are going to be stored. But everything inside the container is going to be in this directory, which for Linux is where we store typically the system and user databases. Now I'm going to use the host name parameter here because the host name is going to map to ADAPT server name. That's kind of convenient, especially when you're doing things like linked servers or distributed transactions. Now, the name parameter is simply a convenience to use with, say, like the Docker client. So when I use other Docker commands, I can reference this container by a known name that I use versus like a GUID that would be the default for what Docker provides. -D is an interesting one. This says, run the process for container in the background. Now, if you didn't do this, it would be an interesting exercise if you ran this without this on your own when you try these labs out. Because what's going to happen is the SQL Server process is going to run as a foreground process, and it's going to dump out the error log on your screen, which is SQL is designed to do as an engine. So we put this in the background so that you don't dump that information out, but it could be an interesting exercise for you to debug SQL if you had a problem running the container. Just take this off and see in the error log entries if there was a problem. And then finally, the last piece of information is, what is the image to run this container? For SQL Server, notice the nomenclature here, and then we have something called a tag. You'll notice here the tag says MS SQL Server and then some long thing, which is like the version, the cumulative update, and what operating system is part of this. And again, I pointed you to the Docker Hub and Red Hat Container Catalog, where we list out all the different instances of the images you would want to use. So in this case, when I run this container, I'm going to be in a pre-installed version of SQL that is SQL 19 based on cumulative update 6 based on Ubuntu 18.04. So that's the specific need I had in this case. So that's how the basics of how to get going and to run a container. Now, in a second here, I'm going to show you a couple of things. And before we do a demonstration, I'll stop and I'll see here whether there are some questions. How do you actually update a container? How do you update SQL Server in a container? You now have installed this container, but you're not sure what to do. Well, first of all, just interact with it like a SQL Server. Use your normal T-SQL, an app to modify data. It's just the SQL engine. We're going to talk about persistent storage in a second, so your databases are all around. And if you want to do a backup restore, I'm going to show you an example where you can take a database backup file and copy the file into the container file system and then restore it within that file system. And then, as we talked about, and I'm going to show you, we're going to use something called a volume to make sure your changes are not lost if the container gets removed. So that's just interacting with changing tables, creating tables, doing normal SQL operations. Well, what about configuration changes? That gets a little more interesting. Number one, I recommend you, as much as possible, use environment variables, which are typically stored in what's called the MS SQL comp file. And there's a link to how to do this for a lot of different configuration needs, whether that be memory limits or whatever it may be. You could modify the container directly with spconfigure and alter server configuration, known T-SQL commands. But remember, once you do that, you've kind of lost the whole concept of containers being consistent. So what I recommend more than anything else is build a new image, a customized image based on SQL, using scripts to use these kind of T-SQL commands to configure the container per your needs. And I'll show you an example of that a little bit later. So, and that's one of the huge promises, I think, of containers is this consistency concept where you can customize things consistently the way you need it. So for example, if you wanted to have a SQL Server for all your developers where max degree of parallelism is set to 4 or whatever you want it to be, you might build a custom image with a script that's going to do that, and the developers use that image. You know it's always the same across all your development, your development group. Okay, let's stop for a second before we do a demo and see what kind of comments we have here. Can you create an instance name in Docker? Server name, instance name. Oh, that's a great question. So there's no concept of named instances in SQL on Linux. We don't have that concept. And in fact, containers are the way to do multi-instance operations. So we'll show you a little example, talk more about that in a second, but that's the way you're going to normally use containers, is create several containers, and each of them now represent an instance. And then the way you can refer to these as names, by the way, is use host name, that parameter I showed you, or also use the Docker client name, so you can refer to them outside the container and inside the container per a certain name. But there's no concept of a named instance in Linux, but that's okay because containers give you this multi-instance concept. Okay, let's flip over and do a demo. Let's do some fun. Let's do it this way by using Visual Studio Code. Okay, what I've got Visual Studio Code pointed to the GitHub repo with all the scripts I told you about. And up here at the top window is the first script to go learn how to run a container. Notice the syntax looks very similar to how I showed you in the slide. And I'll point out a couple things. I'm going to make sure that the name represents the specific SQL Server CU image I'm using, which is CU6 for SQL 19, cumulative update 6. But all the parameters look the same. And here's the name of my volume, SQL 19 volume. That's going to become important here in a second. So I'm going to, at the bottom down here, use the terminal window to kick off and run this. So let's do this. Let's go type in step 1, and we're going to run our container. Now, container images are pulled down from the internet into your environment. And there's all sorts of documentation how to do that offline if you need it on your servers. I have pre-pulled these because if I didn't, it would try to pull it from the internet. I would slow down our demonstration today. So notice how quickly this is run because I've already pre-pulled the image. I'm now running, and guess what? SQL's installed and running. That's how quick it can be once the image is actually pulled. So the next step I'm going to do is I'm simply going to go copy a backup database, notice here this syntax here, I'm going to use the Docker copy command here. See that? And I'm going to take the local database backup and I'm going to copy it into the container that I've just started and into this directory, var optms SQL. Let me scroll over so you can see that. Var optms SQL. What is that doing? That's taking the backup file on my local drive on my Windows laptop, copying it into the container's file system so it can be used. That file system is backed up by this volume concept, which we'll talk a little bit more later about how does that work internally. So I know that my backup I've copied in is persistent. So let's go run a script like this to go actually copy it in. So let's run step 2. I've got these step-by-step for you so you can see step 1, step 2, step 3. It's already done. So step 3 requires a restore. Well, how do I do that? This is interesting. I'm going to do something really crazy. I'm going to use Docker to run another program, another process in that container image. What is that container process? SQL command. Because we install the tools, pre-install the tools inside your container image. So now I can actually go there and run this command inside the container isolated environment as a separate program now as from SQL Server. But since it's part of this container, they're both in the same namespace, so they know how to talk to each other. So here I am simply running this complete restore command because this is where I put the backup itself. So let's go run that. Oops. And this is now going to do a simple restore. And this backup is based on SQL 16, so it has to get upgraded, but the engine knows how to automatically do that since it's SQL 19. And again, this is no different than if I connected outside the container, which I'll show you an example how to do that in the next step. But I wanted to see you different ways how you can interact with SQL. I'm going to run a program inside the container. It's out and it's ready to go. This is an example of how to query it. Now I'm running SQL command as a Windows program on my laptop connected in the container. How do I connect? Well, I already told you. I said use port 1401, and this is the local host because it's just running locally on my actual laptop itself. So I'm running, first of all, a query here to just select data from the database, and then I want to get the version. I want to get the version to show you how version updates and patching are going to work. So let's go run this one. Step 4. And you see here I've got results that are flashing across my screen. And I can see now the version of SQL Server I'm running right here. It's CU6, right? You can see I'm running on Ubuntu 18.04. So what have I done? I've run the container. The image is already pre-pulled. I run the container, and in seconds, I'm up and running. I copied a backup into the file system that's part of the container image itself. Docker knows how to interact with that. I then ran a restore command using SQL command in the container, and I just ran a simple query against it. I could have taken Management Studio on my laptop and done the same thing as these queries right here. But for purpose of automating this, I'm just showing you SQL command. I could use Azure Data Studio as well. That's as easy as it gets to start SQL Server and start running it. We're going to see in a second here, after I show a few other slides, how do I update this? How do I patch SQL Server? Because I said no patching required. What's the magic of all that? We'll show you in a second how that works. Okay, back to our deck here. Let's go back over and see if there's any other questions we got. Okay. So is containers mainly for DevOps or can they be used for production workloads? Wow, what a great question. Checks in the mail. So I showed you just a basics here of using Visual Studio Code, and I talked about DevOps. But remember now, the concept of DevOps is that it is now a production kind of thing, right? But I also talked about how containers can be used in development environments. I'm going to end today's session with a slide to show you that containers for SQL are ready for prime time for production. So we'll explain more about that later in the talk. Okay. Now let's move on and talk about what I just kind of mentioned about multi-instance. So number one, whenever you run multiple instances of SQL Server, a lot of people like to affinitize CPUs or use resource governor, those kind of things. You can use different container runtime options like CPU set or weights and quotas with Docker. Docker supports that. Or you can use SQL commands to do it yourself. I recommend you use SQL commands. Use the power of the SQL engine that we've already provided to affinitize or control how SQL is running from a CPU perspective. Again, one way to do that might be to use like a customized image of SQL. The thing is memory, same thing. Remember I talked about how you would use environment variables? Like I would use the memory limit MB option as an environment variable to restrict the memory for a container, but you can also use max server memory, fully supported. You would again maybe potentially use a customized image of SQL with a script that does that for each instance that you're going to run. Why do I say this? Because a SQL Server container instance, if you have multiple, are all going to use the maximum resources that are provided in the host, whether that's a VM or bare metal. And then finally, networking is interesting. By using the host name, you automatically have some things set up for you. And like a Docker environment provides things like bridge networks to allow you to communicate between these instances. But there is the ability to use what's called a user-defined bridge network to do name resolution. Very helpful for things like replication and DTC. I actually have an example of that. I'm not going to go through that example, but in the workshop, I'll show you just briefly where you can get the scripts to see how that actually works. Okay, what about this idea of patching? Like I said, you don't have to patch your SQL Server anymore. And you're like, I don't believe you. Like, what do you mean? Because think about today in Windows. Today, you install SQL Server 19, general availability. Now you get a cumulative update that comes along from Microsoft, and you want to put on that update. Well, what do? You install the cumulative update. And then the next cumulative update comes along, and then you go install that one. So what you're doing is patching the software. We don't do that with containers. You just use this switch method. So first of all, consider this scenario. You've got what's called a volume, which I've kind of showed you how you might use when you run a container. This is persistent storage of your databases, because each container image has their own private file system. And if they were removed, you'd lose it. But if you use a volume, you're redirected to this known space. So let's say the SQL 17 CU8 container is up and running, pointing to these databases. And you'd like to move to the latest cumulative update. Well, how do you do it? So number one, what you're going to do is you're going to stop the container for CU8. The databases are still here, but you're going to effectively shut down SQL Server. And then very quickly, what you're going to do is turn around and just run the latest container CU based on a new image. And what you're going to do is point it to the same volume with the same port and everything else that I showed you. And now, within seconds, you've updated SQL Server. That's your patch. It's called the switch method. But you're asking yourself, well, that's really interesting. How can I go back? Cumulative updates are compatible between each other. So guess what you can do? If you don't like the results, you could shut down this container and then restart this container, and now you've rolled back. That's how fast it could be, or you could switch back and forth. So when I show this in action, which I will in a second here, people are amazed and think I'm like lying to them, but it's true. And one of the ways you can get away with this is the fact that I'm using a volume where the system databases and user databases are, and I'm using cumulative updates between each other. Now, you can upgrade based on containers. Like I could start SQL 19 and point them to these databases here. And now I've done an upgrade, which will take longer. But because major versions are not compatible between each other, I can't go back at that point. So there'd be no way to switch back to SQL 17. But it does provide a way to actually do a very simple upgrade in line. Now, again, this is just the SQL Server software. If you wanted to take databases and go between them, you can take a database from SQL 17 and apply it to the SQL 19, and we would upgrade that automatically. Of course, you can't restore that backwards. But again, this is just talking about the instances themselves. Okay. So let's talk more about these volumes, because it's really important for you to understand, what do I mean by these volumes and databases going away or not going away? So assume for a second there's a SQL Server container, okay, where the databases themselves are kind of contained in the private file system of that container. But since I've used a volume on host storage, again, the container runtime will take care of all that for you. Since I've got this host volume, the files are actually pointing in this host storage directly. Now I've got a SQL Server 2 container that's not started yet right now, pointing to a separate set of files. Okay, let's say, for example, I stop SQL 1. I stop SQL 1 right here, and then I start SQL 1 again. No difference. I'm just starting and stopping SQL Server, so there's no differences that are happening here, okay? Now, let's say, in the case of SQL 2, I stop SQL 1, or in the case of SQL 1, I stop SQL 1, but I then remove the container. So what happens? I stop the container, I remove it, and notice here that when I do that, the files are also removed as well. Now, again, this is a case where if I go back here, so let me go to SQL 2 and show you that behavior. So let me go back here, back to this. Again, this is an example where the container is not using persistent volume. I'm sorry, I did not explain this clearly. This is SQL run, running a container where the host is keeping the container runtime file system, but it's not persistent because I'm not using this volume concept. So when I stop the container and remove it, I actually do remove all the files because this host storage is backing up the container temporarily. But if I go do this concept where I store the databases on a host storage volume now, okay, host storage volume, and then I go stop and remove the container, what happens? The databases are still there. This is why using volumes are so critical to using in containers. Now, if I go back and look at the scenario, and then I stop SQL 1 and start SQL 2, you're going to see what the behavior looks like, just slightly different here. Ah, look at that. I can point SQL 2 to the same volumes. That's what I showed you in the switch scenario. Because I'll use host storage volumes, notice that the databases, in the case of host storage, are not stored over here. These are the temporary file system spaces for SQL 1 and SQL 2, not the host storage volume spaces. Even though the host is storing them, think of that as temporary storage spaces only for the lifetime of the container. So for SQL, as a product with persistent needed storage, I always want to use this host storage concept. Okay, so let's now go look at what this looks. Let's over, based on our time right now, let me just briefly talk about this, but I also want to get quickly into the demonstration to show you how to go do an update. So I mentioned about this idea of customizing images, right? That maybe you want to customize with scripts and so forth. So you might ask yourself, like, how do I do something like that? So for Docker, if you use that runtime, there's something called a Docker file, which is a declarative file where I can say, I'd like to build my own image, and Docker supports that. You can build an image, then run the image. So I could go into the Docker file and say, I'd like to use this as the base of my image, and I want you to, when you build this image, to copy a backup file into the image itself, to the snapshot. And then the program I want you to run is SQL Server, as this customized. So when this is done, and you build this new image, you can call this whatever image you want. In that image will be the SQL Server software plus your backup. Then somebody could actually just run restore at that point once the container is started. What if you wanted a more script type method? I call this the VinU method because my colleague VinU from Microsoft is the one that showed me how to do this. So here is a Docker file where I'm doing the same thing as before, but what I'm going to do is I'm going to copy in a series of scripts into the image now, and that script is going to be what's going to be run, not SQL Server. The script is going to eventually run SQL Server. So what happens first is this. The entry point script will run two programs. It'll run this shell script and SQL Server asynchronously. Okay, that's what that ampersand means. Then the db init script will wait for SQL to start and then run, because SQL command is installed inside the container, a SQL script. The SQL script can be whatever you want. In the example that I have in our workshop, I show you how to actually run a replication environment, transactional replication, using this method with scripts that build the publisher, subscriber, etc. But this script could be any T-SQL set of commands. It could be spconfigure. It could be creating databases. It could be creating tables. So think now of using this method to build a customized image for your developers on a certain version of SQL with specific SQL configuration options that you want and with all the SQL commands you'd like them to use. You could provide them a complete shell database, for example, based on exactly the schema you wanted them to test on. Okay. And then there's ways, by the way, in this same process to add other packages that we have for SQL Linux, like Polybase, machine learning services, etc. Okay, so let's stop for a second and look at our comments and go back to the actual example I'm going to finish with here. Okay, so let's see here. What is the presentation software website that he's using? I'm not sure what you mean by that. I'm just using PowerPoint, and of course, Simon is providing our environment here that we're using for StreamYard. What do you recommend for separation of the files or for the backups? Yeah, great question. Same concept will apply for production environments. And you have the ability for containers to have separate volumes. So you could have separate volumes to store different files in different locations, depending on where you want that host to go, and the containers certainly support that. Where do you get a link to the sessions that this session is provided? I gave you at the start of the presentation where this talk is, but the last slide I have also has a resource to that. How do I start using C#? I'm going to let Simon answer that for you. And then, does the SQL Docker version have the same functions as the regular SQL Server like Polybase? Great question. The SQL Server container images we have right now are the same SQL Server engine as SQL for Linux. So whatever Linux supports for SQL, we support that. And I just showed you in the very last slide there that the SQL Server container images contain the engine and the tools, but there's ways to install the other packages with your container image, including things like Polybase. All right, let's go do another demonstration here. Let's go back to Visual Studio Code. So here is the script to patch SQL Server. I'm going to run it first, and then I'm going to talk about it. So let's go run step 5. And what is it doing? So first of all, it's stopping the current container. It's running another one. Look at that. Same port, same host volume storage, different host name, different name, and wait for it, different image. This is the CU8 image. So I'm stopping the CU6 image. I'm starting with a new image with CU8. So the CU6 container is not removed, but just stopped. The CU8 now starts up, points to the same databases, and since we're compatible, we handle everything for you in between. So this is running, and it's already finished. So what are we doing in step 6? Step 6, and I won't do this for you, but it's an example of how to run a different container. Let's say that I'm running this CU8 container that's patching SQL, but I want to run a different one. Well, how do I do that? This is a general availability release of SQL 19. Notice a couple things that are different. A different port and a different volume name. I want to separate a different instance of SQL here than the one I'm trying to patch. And this is an example of how to run a second instance. So this is a command just to show you, well, what are the containers running in my environment? So let's go run that one. Step 7. And this is interesting when I run this. When I run this, I'm going to see a couple things here. I'm going to see, first of all, I'm going to see the CU8 image, which is now up and running. But notice that the CU6 image was exited. It just means that the container was stopped, not removed. So the reason why I didn't remove it is I might want to switch back. I could go down here and spec volumes. Let's go run a query and see what we get here. Let's go run step 9. Again, you can run some of these other steps if you'd like to after the fact. This is just running a query. And notice it's running against that. But when it's finished, what do we see? We see now that we've updated to CU8 right here, with the same SQL Server, the same data, the same database. That's how quick it is to patch SQL Server. So, and again, I don't even call it patching. I call it switching or updating. And so if I wanted to roll back, I would simply do this. I would stop the current CU8 container, not remove it, and then start back the CU6 one that I didn't remove, but I just stopped. So let's go do that. So we're in step 10. And now I'm in the process of rolling back. Now, if you're asking yourself, like, do I get to see things like error logs with containers and things like that? Look at step 11. Step 11 says, go run, like I did SQL command before, go run another process that is in the same namespace as this container, but use the bash shell and make it interactive. So look at this. This is kind of fun to do. Let's run step 11 here. Now I am put with a bash shell prompt. But Bob, you're running PowerShell. No, I'm actually put forth a program that Docker supports running in my namespace as a bash shell. Now I'm running in the container itself. So I could say var opt msql log, that directory, and I could do this. I could look at the error log. Looks pretty familiar, right? That's the same error log as you're used to in SQL Server. This is the error log of the SQL container I just rolled back to. So it looks like recovery is complete. It's done. So I now can do something like this. I can go back and run step 14. Well, I'm in the bash shell still. So let's exit out of there. I'm back to PowerShell now. And now I'm running my query again. And when this is the same database I ran a query against, so it's consistent. And now I'm running at CU6. Simple rollback of what I did. I updated my container. I patched it to CU8. I stopped it. I started CU6 pointing to the same set of databases because cumulative updates in SQL Server in the same major version are compatible with each other. That's as easy as it gets. And that's really an amazing way to be able to patch or update the SQL Server version of the software. Okay, let's look at some other questions here before I go back. How do you create Docker container for SSAS, IS, and RS, possibly in Linux? So it's a great question. We do not support native versions of analysis services or reporting services for Linux today. We do support SSIS, though, the DT exec program, and we have some documentation about how you could create a container image for that. Are you running an admin mode with Azure Data Studio PowerShell terminal? I'm just running the terminal on my local laptop, so I'm not running any special mode there. I'm just using actual Visual Studio code, but great question. I could have done this in Azure Data Studio. I could have used Azure Data Studio as my environment and ran a terminal inside it and ran queries in Azure Data Studio as well. So that would be a great suggestion for the future. I do like using Visual Studio Code for just raw developers, But Azure Data Studio is a great environment where it supports a similar environment just like this. And it does support PowerShell notebooks. So another way to do this is to take these PowerShell scripts, put them in notebooks, and then run them from that perspective. All right, let's go back over to our PowerPoint presentation. We've got 6 minutes left, a little bit pressed for time, but that's okay. If you think about it, let's just stop and think what I've done, right? I've talked about the power of containers, why you want to do it. I've talked the basics about how to get these things up and running. I showed you some examples of how simple it is to do that. And then I showed you this idea, it's pretty cool, of running multiple SQL instances as containers, but even this amazing story of how to go patch a SQL cumulative update without truly patching the software. In fact, that is the world you're in with containers now. Don't patch anything. Just run a different container image and point it to the persistent volume storage that you already have in place. Okay, so this question was asked earlier. Are containers ready for prime time? Remember, a container for a SQL Linux image is just a SQL Linux process run in an isolated manner. So I have seen this stated before when I was on the road, the last year. Oh, I wasn't on the road last year, maybe the year before. But just in general, I've seen this from the community. Containers aren't as fast as SQL Server. I'm like, that's not true. If you're running SQL Server on Linux as a Linux image, remember that first slide I kind of showed you earlier, it's just a Linux native process. In the book that I wrote, SQL Server 2019 Revealed, I show you a test of using the popular open source tool HammerDB. A TPCH query runs 100% the same on a SQL Server on Linux as a SQL Server container on Linux. Again, if you're running in a SQL Server Linux container on a Windows machine, that's not fair to compare that to SQL Server on Windows because there is a slight virtualized process there. Now, it may be fine for your needs, but I would not run that as a production workload. I would make sure that if I need to run SQL Server containers in production, that would need to be on a Linux system, a VM or a bare metal machine. But for development purposes, it's perfectly fine. Now, SQL Server 19, we run our containers as non-root now. This is something that we needed as a requirement to run environments like OpenShift in Kubernetes. So if you have concerns that our container images run from root permissions, they don't anymore. That's a change we made in 19. And then I always get questions about licensing. How does licensing work for containers? It's the same as virtual machines. In fact, we have a specific section in our licensing guide for SQL 17 and 19 where we talk about exactly how containers are licensed for how you purchase SQL Server. But keep in mind this. If you run developer version of SQL Server with, say, Ubuntu, everything's free. So you as a developer can be out there developing for free on your MacBook, on Linux or Windows with no charge at all using SQL Server Ubuntu-based images for Developer Edition, and that's the default. So when you run a SQL Server container, the default is Developer Edition. You have environment variables to specify if you want to run in production that it's Enterprise Edition. Now, consider this about production workloads. Most production workloads for containers are going to gravitate towards Kubernetes, which is a scaling environment to run containers. In fact, our big data cluster solution we have with SQL 19 deploys some 50 plus containers, including SQL Server in multiple instances to actually make that solution happen. We just recently announced Active Directory authentication support for SQL containers. So if that was something that was blocking you from using SQL containers, we've removed that limitation and we have documentation how that works. And here's just a couple examples of customers I've worked with that are running in production today. DV01, one of our early adopters of SQL Linux, and Balzano, which happens to be running big data clusters on Kubernetes today. And it is an example of the power of SQL could be ready for you for containers for production. Okay, quick takeaways. They're portable, they're lightweight, they're consistent, and very efficient. Think about this idea. Maybe containers for you can become database containers. Maybe it's no longer thinking in terms of it's a SQL Server thing now. You build a container image with your database, with your scripts, with the SQL Server image you want, with everything you need in it. And you just give it to a developer and say, hey, there's your database. Go start using that now and not worry about all the intricacies of the SQL instance itself. Now, we talked about deploying. We talked about how they support DevOps. We understand how they work now, this new way of patching. And then I mentioned exactly that I think they're suitable for production environments. Keep it in mind, a SQL Server Linux container is the same process as running SQL Server on Linux itself. It's just run in an isolated way. Here's some resources for you. Shameless plug for books, right? There's a book on Linux I've written in 2018. In 2019, I wrote a book, and there's an incomplete chapter of how SQL containers work, including a lot of stuff I showed you today with more that you can go take a look at that. Here's all the references. This is where the deck is. This is where you go get all the demos I just did. More demos here, more demos from the book. and then great talks you can take a look at. Here's a great talk that Vin, you did at Ignite a couple of years ago on how to do containers with DevOps. And then here's the video link from Build 2020, where you can see me show you exactly how to use Azure DevOps with SQL Server. And then here's a great book just in general to look and see how to get up and running on Docker. It's a great just general resources on how to use containers itself. I really appreciate your time today. Let's see if there's any other questions here. Have some documentation for AD authentication containers. Yes, Wilson, once you get this deck, if you go back here and look, I've got a specific link for you. You can click on right here, and it shows you exactly how to go do that. And what about Podman from Red Hat? We certainly support the Red Hat environments. We prefer that what people use with Red Hat today is like an OpenShift environment. I don't know specifically all the details about using Podman, but just to let you know, our images are compatible with running Docker as a client, but they're also compatible running other container runtimes because we support SQL Server running in Kubernetes. And in many of those environments don't use Docker, they use other type of environments. So, hey, thanks so much, Simon, for your time today. That was certainly a fast-paced look at SQL on containers. But I think hopefully everybody here got the idea of the power what they can provide and the value they can be for both developers and every professional out there that wants to use SQL in this new way to deploy and run SQL Server.